So here's our second video about looking at the equation of a quadratic in its complete square form and its graph. And you've made some notes, and let's see if we're on the same page about this. So the first thing I'm going to do is going to move the value of k and see what that affects. So if I make k bigger, the graph gets narrower. So it's changing the shape. Okay. If I make k smaller, it's getting wider, and then if k becomes negative, then I get an unhappy face, and again, as it gets more negative, it's becoming narrower and narrower, okay? But what you will also notice is that the turning point doesn't change. So what affects the turning point? Well, that's A and B, and I'm going to show that by going into box 5 here and typing the point A, B, and putting a label on it. So you do that too. Now let's see what happens if I move A. Well, if I move A, then the point that I've plotted is still the turning point wherever A is, and that's the same with B. So if you have an equation of the form x minus a all squared plus b, then its turning point is always a, b. Now the last thing I want to show you is how we work out the equation of the axis of symmetry. So the axis of symmetry for this parabola, as it is for all parabolas, is a vertical line that goes through the turning point. So in box 6 here, I'm going to type in the point x equals a. Okay, and I got another red line here. And as you can see, it does split it exactly into two. So what happens when I move A? When I move A, that vertical line is still the axis of symmetry. So the axis of symmetry for an equation of the form at the top here is x equals a, or x equals the x coordinate of the turning point. Okay, so make any notes you need of this and then move on to the next task.